Okay, so about the Schrödinger's thought experiment, Schrödinger's cat thought experiment. So it's kind of a philosophical experiment thought by Schrödinger's, an Austrian scientist, something that you can perform a real experiment on. So here's how it goes in his experiments. So there is a box that can be sealed, and there is a cat, a live cat at first, and then you put in a poison there and some radioactive material all into the box. So it goes there that if in the radioactive material an atom decay, it will trigger the poison to be released and kill the cat inside a box. Now, this radioactive material has a 50% chance of having an atom that decay in a course of 1 hour. So that means within 1 hour, there's a 50% chance that an atom decay, triggering the poison to be released and kill the cat. But there's also another 50% chance that in that 1 hour, no atom decay, so no poison are released and the cat is alive. Now, the box is sealed. No one can see what's going on inside until you open it. So before you open it, no one actually knows whether the cat is dead or the cat is alive. So before Schrödinger's thought experiment, there's already a Copenhagen group of scientists that call a Copenhagen interpretation of quantum mechanics. So according to that, it would mean that according to Copenhagen's interpretation, the cat being alive would be one waveform, cat being dead would be another waveform. If you have no idea which one which outcome is going on before you look into it, then both can exist at the same time, called quantum superposition. So the point of this Schrödinger's thought experiment is to point out the flaws of this Copenhagen interpretation. It's a bit illogical to think that, a bit ridiculous when to think that how can a cat be both dead and alive at the same time? So it follows that in terms of quantum mechanically, Copenhagen's interpretation is much more, works better. For example, an electron, it does have a quantum superposition as been observed in interference experiment. So in terms of electrons, then quantum superposition occur, both states can occur at the same time. But when you look at a life-size material like a cat, having quantum superposition that the cat is both dead and alive at the same time doesn't seem to work anymore. So it seems that things that behave quantum in the quantum mechanics level might not behave the same way as things on a real life-size macroscopic
so
level.
The one you said over there, the radioactive isotope,
some radioactive material.
Some radioactive material, when there's a 50-50 chance it decays. So how is it related to the poison?
In the real thing is that in the full thing is like a radioactive material. Then you have a Geiger counter that counts that have a count every time an atom decay. Yeah. So when the Geiger counter actually receives a count, it will trigger the hammer to break the glass of poison. So I just simplified.
Oh.
Well, it's just a thought experiment.